Hey, 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 ahoy, ahoy. Welcome back to part 4 of the review notes for Unit 5 Definite Integral. Okay, we've done 3 already. This is the 4th and final video. And I believe where we left off, we learned the Trapezoidal Rule, Simpson's Rule, and now we have 3 problems to do, numbers 1, 4, and 5. So let's get started. Here we go. Number 1, calculate the approximate area of the shaded region. Okay, and you'll see right here, this is a graph of x squared. Okay, so calculate the approximate area of the shaded region in the figure by the trapezoid rule. Okay, using the divisions at 4/3 and 5/3. Okay, I'm going to redraw this out so it's a little bit bigger. All right, extendo. So I go right here. And I have got 0, 1, 2, and I go up 1, 2, 3, 4. Okay? Now, I'm going to make a table to make life easier. And y, that's the same thing as taking whatever x is and squaring it. I know I'm starting at 1 and ending at 2. 1 squared is 1, and 2 squared is 4. So I'm going to plot those points right now. 1, 1, and 2, 4, right up here. Now, I know that's a y value of 1. This is a y value of 4. Right? But I also need to put 2 more divisions in here at 4/3 and at 5/3. Okay? I should know 1 is the same thing as 3/3. And 2 is the same thing as 6/3. So you can see it goes from 3/3 to 4/3 to 5/3 to 6/3 and so forth. Okay? So I need to find the y value when x is 4/3 and when x is 5/3. The good thing is I know how to square fractions. I square the top and the bottom. So squaring 4/3 gives me 16/9. Squaring 5/3 gives me 25/9. Okay? So if I were to plot those, 16/9 is just short of 2. So maybe right here. That's 16/9. I'm just writing the y value. And at 5/3, it's 25/9. That's short of 3. Probably somewhere around here, that's 25/9. Okay, so I got this kind of curve. Boom. There you go. It's part of my parabola. And remember, I want the area under the curve between 1 and 2 here. But we now have 3 subintervals, okay? So what I'm going to do is as follows, okay? I know my trapezoid rule tells me, okay? I take my width or my height, whatever you want to call it, and divide that by 2. My first y value, I don't do anything to. I add that times 2 times my next y value plus 2 times my next y value. And I only have 4 y values here, so plus the bookends do not get doubled. Okay, so this is what we consider y0. This is what we consider y1. This is what we consider y2. And this is what we consider y3. Okay, so I'm going to put those in. Okay, so it is 1 plus 2 times 16/9 plus 2 times 25/9 plus, and this last one does not get doubled, 4. Okay. Now, what is my width? It's the width of each one of these. It should be the same amount, and that is, my friends, 1/3. Because to get to 3/3 to 4/3, I add a third. 4/3 to 5/3, guess what? I add a third. And 5/3 to 6/3, I add a third. So I'm going to take 1/3 and divide it by 2. Okay, let's do the algebra. At this point, it's just, we've set it up. We're just doing algebra now. So if I take this right here, and I take 1/3 and divide it by 2, dividing is like multiplying by the reciprocal, right? That's like 1/3 times the reciprocal, 1/2. That actually ends up being 1/6. Okay, this is going to be a 1 plus, okay, if I do this math, it's 32/9 plus 50/9 plus 4. Okay, well, as far as inside my parentheses, let's make everything a number, a fraction that ends in 9, or that has a 9 as a denominator. 1 is the same thing as saying 9 over 9. 4 is the same thing as saying 36 over 9. Okay, now I can combine all those fractions. I still have 1/6 times. Okay, 9 and 32 is 41. 41 and 50 is 91. 91 and 36 is 127. So I have 127 over 9. All right, now I just multiply the tops and the bottoms. 1 times 127 is 127. 6 times 9 is 54. Okay, this is the area under the curve. That number, 127 over 54, represents this area under the curve. Boom. And guess what? 127 over 54. Oh, look at that. Perfect. The answer is D. Nice. It's all setting up our trapezoid rule and using it. The second problem, which is number 4, crazy. A table of values for a continuous function f is shown above. If 4 equal subintervals from 0 to 2 are used, which of the following is a trapezoidal approximation of the integral, which is, again, represents the area under the curve of this right here? I like to draw me some pictures, okay? So this is what I do. I cannot create my subintervals by going right on the lines. I've learned that the hard way, okay? My subintervals, 4 of these, if I take 2, okay, this goes from 0 to 2, right? So if I take 2 and divide it by 4, because I want 4 subintervals, that means each subinterval should have a width of 1/2, or 0.5, okay? That means I'm going to start right at 0 and go to 0.5. You see, I'm going right on them. That's my first subinterval 1. Okay, subinterval 2 will go from 0.5 up 1/2 to number 1. That's subinterval 2. Okay, subinterval 3 goes from 1 to 1.5. And subinterval 4 goes from 1.5 to 2. That's subinterval 4. That is 4 equal subintervals, okay? Which means my y values, okay? This is y1. I should highlight that. I always say that when I don't want to cover up numbers. y1, or y0, y sub 0, y sub 1, y sub 2, y sub 3, and we'll use orange, y sub 4. Those are my 4 or 5 subintervals. There's 5 subintervals, but when I start at 0, it goes to 4. I know, it's confusing. Let's set up our trapezoid rule, right? It is our width divided by 2 always. My first one, y sub 0, doesn't get doubled. That's a bookend. And if, okay, this is y sub 0, 1, 2, 3, 4. My y sub 4 also does not get doubled. Everything in the middle does. I double y sub 1 plus double y sub 2 plus double y sub 3. Okay? That's always the way it works. And I'm just subbing in values. What's the width? My width is 0.5. The width of all of these is 1/2, which is 0.5. So I could take 0.5, and I divide it by 2, times my first y value is 3, plus 2 times my next y value, which is 3, plus 2 times my next y value, which is 5, plus 2 times my next y value, which is 8, plus my last y value, which is 13. Okay, this is a lot easier than creating a table and figuring out the y values for yourself. I love when they give you the table. So now, half of 0.5, half of 50 cents is a quarter. Okay, this is 3, this is 6, this is 10, this is 16. So let's add these. 13 and 16 is 29. 29 and 10, 39. 39 and 6, 45. 45 and 3, 48. 48 divided by 4 is the same thing as 48 times 0.25. That is 12. Let's take a look and see if we have an answer up here. It's 12. Oh, B. 12. Yummy. Last one, number 5. Let's create some room here. F is a continuous function on the closed interval from 2 to 8 and has values that are given in the table above. Using subintervals at 2 to 5, 5 to 7, and 7 to 8, what is the trapezoidal approximation of the area under the curve? It's the integration of f of x. Okay, now I have one subinterval which goes from 2 to 5, subinterval 1. Then I have a subinterval that goes from 5 to 7. That's subinterval 2. And then I have a subinterval that goes from 7 to 8. That's subinterval 3. Here's the problem. The width is not the same for all of these. So for subinterval 1, the width from 2 to 5 is 3. Okay, that's a semicolon. For subinterval 2, the width goes from 5 to 7. That's only a width of 2, semicolon. And for subinterval 3, well, that only goes from 7 to 8. That width is 1 for subinterval 3. So what we're going to do is we are going to do the trapezoid rule separately for each subinterval. Okay, so what do I mean? I still have to do this. Okay, my subinterval for the first, or my trapezoid rule for the first subinterval. Okay, I still take my w and divide it by 2, and I multiply it times all my y values. Remember, the bookends don't get doubled. Everything in the middle gets doubled. Here's the problem. I only have 2 values. I only have my bookends without any books in between. So I don't have to double this at all because I have a bookend, and nothing in the middle. So if I were to do a regular trapezoidal rule, w divided by 2, y0 plus 2 times y1 plus 2 times y2, so forth, and then your last one does not get doubled. I have the ends. I have nothing in between, and that's fine. Okay, that's good. So my w here is 3. So it's 3 over 2 times 10 plus 30 is 40. Okay, and if I do my math here, I get 60. That's for subinterval 1. But I still got to find the area under the curve for subinterval 2 and subinterval 3, and I got to add them all together. Because all I did was find the subinterval. This number right here is just the area for this. I want it all. I still got to do the other 2 subareas. So, green, my width is 2. I put that over 2 times. Again, I only have 2 y values, 30 and 40. Okay, so 30 plus 40. I have no in between. I just have bookends. Okay, 30 plus 40 is 70 times 2 over 2, which is 1. That's 70. That's the areas for subinterval 2. So when I go here, 70 is this area right here in between. I found that out. I got to add that to my last one. Okay. Now, in blue, my width is 1 over 2, and the 2 y values are 40 and 20. Well, 40 and 20 is 60. Half of 60 is 30. That's the area for subinterval 3. Highlighter, highlighter, I love you. So here we go. If that's 30, that's the area here. But I want all of this area together. So I've got to add them all up. All right? So I have 60 plus 70. 60 plus 70 plus 30. That's 100 plus 60, 160. C. Kadoosh. Done. Beautifully done, might I say. And right. Wouldn't that be funny if I did that and it wasn't right? I just paused the video and then I checked the answer and it was right. Because if it wasn't right, I would have had to delete this whole video and start over and it would have been embarrassing. Which I did once already, but you don't know because I deleted it. Interesting. Anyways, there you go. We did problems 1, 4, and 5. Not bad. Not bad at all. Now you have packets upon packets upon packets of integrations to do. Oh, the fun you'll have. The places you'll go when you learn to read. That's Dr. Seuss. But he was really a mathematician, so he wasn't. I lied. I'm sorry. Ring the bell, like this stuff, share this stuff, follow this stuff, do everything, and good luck. And thank you for hanging on this far because calculus is a fun little journey, but it's difficult. And if you get it, you'll be fine. You'll be fine. All right, I guess I will see you for Unit 6 review. I can't believe we're up to 6 already. See ya!